Thanks very much, Johan. It's really nice to be back here again. I'd like to start with a little apology. I'm quite embarrassed about the fact that I was asked to come to here and talk about planetary boundaries. It's kind of like taking coals to Newcastle. So I've worried a little bit about how to do it. And this was the title that I was given. Are we likely to hit planetary boundaries before 2050? Well, actually in our paper we said we've already hit 4 of them. So I kind of scratched my head and said, how do we do this then? And so what I'd like to do is not so much present the planetary boundaries as to try and look at what the planetary boundaries mean in a larger perspective, kind of taking a helicopter view on where we are right now. So I want to change my title to something like, can we develop mechanisms to manage global resources at the global level by 2050? And that's actually, I think, a more challenging question than whether we're going to hit planetary boundaries, because we've already hit them. It is my premise that we all know we're living in a very exciting time, but one of the things I think that makes it such an exciting time is I do believe that we are in the process of recognizing, both as individuals but also as a society, that we need to do management of our resources at the global level. I presume that our ancestors a very long time ago, when they produced waste products, whether they were bodily or otherwise, they let them fall right where they were produced. I also presume that those same ancestors, when they needed energy, they went out and they took whatever they could find that could be burned, and they got their energy. When they got to be a certain number of them, they realized, oh, there's no more trees here. We need to make some rules about who can take trees and replanting trees and so on. They also realized they were becoming sick because the water supply was polluted with their bodily fluids and so on. So rules had to be made about where you could put waste and what kinds of waste you could put. And so they recognized that they needed to do environmental management at the local level for their own sakes. Not for the sake of the planet or not for the sake of the environment. They're both still going to be here, but for their own sakes. We also recognize, especially if we live in an area like Europe with many small countries right up against each other, that we also have to do regional environmental management. I mean, if we want clean water around Denmark and Sweden, if the Poles and the Germans and everybody else in the Baltic are still throwing their rubbish in, we're not going to have clean water. So we recognize we need to do regional management for our own sakes. And what science is telling us very clearly is we need to do global management for our own sakes, not for the sake of the planet and not for the sake of nature or the environment. I believe that this particular phase that we're in is actually started when humans went out into outer space and could see the Earth. Take this picture. I know you've seen it before because I've been told that it's the picture that's most downloaded from the internet. There are 2 things about this picture that are so obvious. You've seen it before, and you know, when I say it, but I guarantee you've never really thought about it. The first is our ancestors made a terrible, terrible, terrible mistake. It should never have been called Earth. It should have been called water or ocean. But the other, and even more pertinent in this context, is it doesn't have an umbilical cord. You say, okay, well, that's pretty obvious. What's she trying to get at here? But if it doesn't have an umbilical cord, it ultimately means that the resources upon which we base our development are limited. Now, I know it's been said for years and years and years, but when we were at Rio +20 a few years ago with the planetary boundaries story, the Heartland Institute and other conservative think tanks in the United States, there's absolutely no scientific evidence whatsoever that there's limits to what you can take out of the planet. Come on, there's no umbilical cord. So I think this is the phase that we're in, and the way that we're recognizing it is through climate change. Now, climate change is really interesting. There are 2 very special things about climate change, I think. One is it elicits a completely non-standard response in the general public compared to most normal, I would say, natural science studies. Normally, as a natural scientist, people don't really care what we do. I mean, we're not very interesting unless we can develop something that can be sold, a product, or something that makes a process faster, more efficient, so that, you know, somebody can make money on it. Otherwise, we're not really very interesting until we start working on something that challenges the way people like to think about themselves and their relationship to the world around them. Think back to poor old Galileo. He was imprisoned in 1633 for saying he thought Copernicus was right and that the earth revolved around the sun and not the other way around. Does anyone remember when the Catholic Church said sorry? 1992. Pope John Paul said there might have been some mistakes in the Inquisition. But we don't have to go as far back as Galileo. We can go back to Darwin in 1859. What did he really do? He challenged the way people thought about their relationship to nature and the environment, the planet. Because the Bible had said that we were somehow elevated above nature, and it was a God-given responsibility, not right, but responsibility for us to go out and bring civilization to that wildness that was nature. And then this scientist comes along and he says, nah, we aren't actually better than nature. We're not above nature. We're part of nature, like every other organism. That was difficult to swallow. But even worse, he challenged the economic paradigm of 1859 because there were very many people that didn't think you could have economic growth or stability if you didn't have slaves. And along comes this guy and says, nah, these aren't animals that you're selling, they're actually our brothers. And that really takes the carpet out from under the business. Now fast forward to climate change. Most of us, I guess unless we live in Kansas, have accepted the fact that we do belong to a species, but that the combined activity of that species can be enough to influence the way the whole world works. That's really, really hard for people to swallow. And what's worse is it challenges the way that we think about our the possibilities for economic growth and stability, because there are very many people that don't think you can have it if you don't have access to fossil fuels. So in many ways, we haven't come all that far. It's interesting to me, people in Denmark think they know me, they've seen me on television, and so I've been in their living rooms in that sense, and so they feel quite free to come up and tell me, they see me on the street and tell me what they think, and I've discovered that they tend to do it mostly if they don't think the same things that I do. And I've had people stop me on the street and look me deeply in the eye and say, I do not believe in the greenhouse effect. Okay? So I've discovered the way you deal with it is that you put the other foot forward, look them deeply in the eye and say, that's very nice. How do you feel about gravity? The point is that climate change is different than many other scientific issues that we deal with, and it's not something we're going to convince people with a whole lot more graphs and a whole lot more data. This lies much, much deeper, and I am tired of scientists using wet noodles to whip themselves on the back to say we haven't communicated this well enough. Evolution has been communicated for 154, 5, 6, 7 years now, very, very well, very convincingly, and there are still over 40% of Americans that say they don't believe in it. Okay, the other thing I think that's interesting about climate is the fact that I call it the first wide-scale appreciation of a need to manage environmental resources at the global level. You can say that the ozone level was the first one, but it influenced so few people that it didn't really count. So climate is interesting, but it's not alone. It's really only a proxy for what we need to do, or the challenges of what we need to manage. And we see this from the great acceleration graphs that I'm sure most of you already have seen, but they're all starting in 1750, they all end in 2010, and they all represent, on this side, all these red ones, present something about the human enterprise. And you can see this massive acceleration, and if you go over to the Earth system, it turns out that you have the same kinds of pictures going on here, obviously correlated. You all know perfectly well that a correlation does not show a cause and effect. There were more babies in Germany as there became more storks, and I hope I don't disappoint anyone if I tell you there's no evidence that the storks brought the babies. Nevertheless, in all of these cases, there is a cause and effect relationship demonstrated between human activities and the changes we're seeing in the system. Why? Because our growth, our economic well-being, our quality of life is based on us using these resources. They are our real currency. None of us would use more money than absolutely necessary to buy a good or a service, but we all use more resources than are necessary to supply our needs and even to keep the quality of life that we have right here and now. I showed an earlier version of these in these curves at a huge meeting in Tokyo some years ago, and the guy who was supposed to be challenging me on this said, "But I just can't imagine humans demanding less resources." And I said, I can get my head around that, because it is hard to imagine, and it's certainly an impossible or a very daunting prospect. On the other hand, can you imagine these curves continuing? And the answer is clearly no. So something's got to happen. And basically, that was what caused some of us to get together a while ago. This was the first paper for the planetary boundaries. But rather than talk about the paper itself, I'd rather talk about what I think it really means. I think, and Johan may disagree with me, but I think in a way what we were saying, mostly as natural scientists, there are some others there, but mostly as natural scientists, is it's all very well and good to be a natural scientist and collect data 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 and plot it all up and make the curves that we just saw in the acceleration. And we can look at those curves and say, ew, we did something we never should have done. But can we use our understanding of the Earth system to go the other way around and say, are there some places, can we identify some places that we don't want to go? So instead of coming after the fact, being more proactive and trying to identify where we might not want to go. Now, the whole premise, of course, is based on our understanding, actually, of systems. And systems understanding starts with us. I mean, if you break your leg, the doctor may be able to put it back together again, and it'll still function as a leg, but it'll never be quite the same. It won't be as strong. It may hurt when it gets wet and cold and so on. There's been a state change. It still functions as a leg, but there's been a state change. We see it in ecosystems. We see it, for example, if you have a clear lake that has plants growing at the bottom and gets light down to the bottom, then you put in extra nutrients. And the water gets all cloudy because those wonderful phytoplankton, whom I happen to love in my other life, but those wonderful phytoplankton come up in the top and they shade out the bottom plants. Now take away, and they disappear. Now take away the nutrients. Do the bottom plants come back? Where should they come from? So you've had a state change in that ecosystem. We see it in other kinds, in grasslands to shrubs, in corals to algal dominance. It can be human caused or it can be natural causes. But we see these changes all the time in ecosystems around us. So then the next question becomes, can the Earth have different states? Can we have Earth system, can we have changes in the state of the Earth system? And the answer is clearly yes. This is a proxy of temperature on the y-axis here, which is actually coming from some research from the University of Copenhagen, from the ice cores in Greenland. And basically those huge jumps that you see there they're 10 to 12 degrees in the course of a decade. They're huge. And clearly the Earth has had a rocky road, and our ancestors, at least some of them, survived it. I emphasize at least some of them because we know from genetic studies that at some points in time we were down to tens of thousands of reproducing individuals. That's not very many. We're very lucky to be here. But basically humans in the form that they have today have been around for about the last 250,000 years. Some of them didn't make it through. Some did, fortunately, otherwise we wouldn't be here. But the ones who did make it through, how did they make it through? They made it through that when the water came up to here, they went over there to keep their feet dry. So they were constantly in motion. What's really interesting, though, about this picture is these last 12,000 years, which is what we call the Holocene. And it is a period of exceedingly stable and relatively warm climate. That relatively warm is important because it has to do with where the rain is distributed and so on. And it's only in this period that humans have developed what we consider modern civilization. That's when we figured out how to do agriculture, sort of 4 or 5 places independently of one another. And many anthropologists think the reason that we did it was because we didn't have to run around keeping our feet dry. We could sit down on a stone, see the acorn fall from the tree, see it beat, oh, I can do that too. But even in Australia, where they never got around to doing agriculture, in this period we see there were huge increases in the numbers of Aborigines there were in Australia. So there's something about this particular state of the Earth system that is really good for humans. This is the only state that we know for certainty that modern societies can be supported. And therefore, we might have the technology, as some people claim, to be able to manage the other states, but we don't know that for certain. So the precautionary principle says really would be dumb of us to try and do anything that could move us out of that state. Now, I should be honest and say the major reason for that stability there is that the Earth's orbit around the sun at the moment is particularly circular. And you could say that could change tomorrow. Doesn't make any, so I don't need to worry about it. But there are people who wed their entire lives to understanding the orbit of the Earth around the sun. And they say, no, thousands of years are left of this orbit. So unless we do something that pushes it out of this system, there's no reason to believe it'll go out of this state. So basically what we did in the planetary boundaries is identify 9 different processes that are important for maintaining this state and which humans are impacting greatly. There are other processes that are important, but where humans aren't impacting them, these are the ones that we identified. Now I'm going to show a picture that Johan will probably choke on, but it's an old picture from the first study. And why I like it is that it, for the first time, actually puts resource use, human demand for resources in economic language. Basically, we identified, for 7 of the 9 boundaries, we identified or proposed a boundary that should not be surpassed by humans. By the way, I will say it now, I'd saved it for a little later. I am so unhappy we called it boundaries. Because boundaries implies that when you hit it, you fall off the edge. And we've had a lot of problems with that. And even the way you asked me to do this title, are we going to hit boundaries? For God's sake, we're already saying we're on the wrong side of 4 of them. And the way I think about these boundaries is rather like blood pressure. We have no guarantee that having a blood pressure over 120/80 is going to create a disaster or be a disaster for us. But it does increase the risk, and that's why the doctor tries to put it down. Same way with smoking. If you're a smoker, you have a risk of getting a smoking-related disease, but no guarantee you'll get a smoking-related disease. Stop smoking, and you get back to an almost even keel, or the same risk as a non-smoker. But I don't, maybe this is, I can't figure this out. But basically, if you take the black line there as being the supply, because that's where we propose the boundary should be, then you can actually, through time, look at the human demand. And the really interesting thing is at the beginning of the Industrial Revolution, or just before the Industrial Revolution, our demand for resources was so small compared to the supply we could pretend that it was unlimited. That we have done, and that we continue to do. The problem is, as time has gone on, we've moved out of these axes, and in the last time we only found 3 on the wrong side. Now we have 4. But the point is, we can begin to understand human demand for resources in a demand and supply mode, which is something that resonates with people. And in fact, it resonates so much that, to our surprise, planetary boundaries was picked up by a lot of policy people. That really wasn't the intention when we started it, and it's caused me to rethink my relationship, or the relationship that I think science has with policy making. Because I'm from that generation, that very old generation, that was basically, my professor said to me, listen, if you really feel compelled to give your results to policymakers or decision makers, then run by the table as fast as you can and throw the results on the table. Don't get your hands dirty by talking to them. Mm-hmm. And we scientists very often say, this is relevant for policy because this is, but we don't actually ever ask policymakers what's a good packaging. I believe that policymakers should never ever decide what we should research in. They should never decide how we should research, but I've come to the conclusion they have every right to tell us what kind of packaging is useful for them. And they like this packaging because it helps them to prioritize. It helps them to balance, what are the most important things to look at first. And that, of course, made us, I think, that one of the things that moved us to do a Planetary Boundaries 2 paper was very much the fact that, that it did have a form that people were using and wanted, and we had a moral responsibility to try and solidify the science, and we still do have that moral responsibility. So we came with this new paper this year. I don't want to go into it in detail, but one really interesting thing about it that emerged is that we now, instead of giving all 9 of these boundaries kind of equal weight, we say there are 2 core boundaries, and that the other 7 actually operate through those core boundaries. And what are those core boundaries? They are climate, because climate has to do with how much energy you have at the surface of the Earth. The other one is biosphere integrity, what we used to call biodiversity. Now, why biosphere integrity? Well, because if you didn't have biology on this planet, you'd have the energy that the sun's giving it, and you'd have lots of building blocks, elements, molecules, and so on. But basically, except, when lightning strikes and you have some nitrogen that hops around, those building blocks are pretty immobile and pretty inert. Put biology into the picture, and suddenly you transform and you transport all these building blocks. And basically what evolution has done is every time it was thermodynamically reasonable to be able to use the energy from a conversion of these building blocks to for something constructive, biology went in and created an organism that does it. So the 2 things that really make this planet are the 3 things: the geological building blocks and molecules and elements, and then the energy that you have to play with, and then all those wonderful biological processes that make it what it is, give it oxygen in the atmosphere, ozone layer, and so on and so forth. And all of the other boundaries, as I say, operate through it. Now, this time we arrived at the conclusion. We changed some of the control variables and so on. I won't go into detail here, but we did arrive at the conclusion that for 4 of the boundaries, one being biosphere integrity, land system change is something that we also arrive at this time. Nitrogen and phosphorus flows and climate are the ones that we feel were on the wrong side of the boundary. Now, the boundary in this drawing is at the end of the green area. And the other thing about calling them boundaries, and when people think threshold, it's actually on the safe end. Basically what you do is you say, okay, if all of science says that we're going to have a threshold at this point, then we the average on this point, then we take the sort of the confidence intervals around that, and at the lowest side of it we say there's the boundary, because the risk starts to increase as we approach that threshold. And the reason for doing that is if you're going to use these in any sort of policy sense, you need an early warning. You need to be thinking, here we have a problem. So again, I'm a little concerned about our choice of wording here. If we run through it in the same way, we can say the first boundary that we actually hit hard, that was the biodiversity, the biosphere boundary. We've been taking out the large organisms, possibly all the way back to the megafauna, for centuries, and changing the way that, material flows on this planet. We start moving out in the Green Revolution. We start moving out of some of the other axes. But what's really interesting is in the 1990s, we were on the wrong side of the boundary for ozone depletion. And if you go to today, we're on the right side. Now that's a really, really good and encouraging story, because it does mean, even though I know ozone was something that didn't really affect a lot of people and it was easy to find a mechanism to do it, we did actually manage to do it. Now, the other thing which is really interesting about the whole planetary boundaries concept, and about the SDG concept, and about basically about climate actually, is the fact that the moment you admit that something is limited, that there is not an unlimited amount to take of it, then you have to start talking about how you're going to share what you have. And that's been one of our big problems with the planetary boundaries, because the United States went dead set against it at Rio +20, because the sky's the limit, not the Earth. And the G77, speaking for the developing countries, went dead against it because every time the developed man says there's nothing left, guess who doesn't get any? And that's exactly what we're doing in climate right now. We know basically the size of the common garbage dump that we're sharing with every other person on this planet. We know it's half filled, and what we're negotiating is who gets the rights to the last half of that resource. Those of us who use the first half could turn around to those that haven't had a chance yet and say, it's all yours. That ain't going to happen. So that's what's dragging it all out. And of course, as long as energy use, CO2 emission, is the same thing as economic growth, is so closely linked to economic growth, we are negotiating who gets the right to grow and develop. That is heavy stuff. Anyway, in this new paper, we do also go in and try where it's possible for some of these resources to look at what the distribution looks like on the basin scale. And here you can see the really red areas where there's really heavy nitrogen release of reactive nitrogen. And we know that if we put more nitrogen on sub-Saharan soils, for example, we get more food produced there. But we have these wonderful development policies that say, we'll be happy to feed the hungry people in Africa, but it has to be our farmers that get to use it. So look where we're using that. Maybe we should just transport nitrogen to them. That might be a better idea than bringing them food, but that's a rather controversial topic. Water is another issue that we can look at here, and we do others in the paper as well. But I'd like to finish off by saying that planetary boundaries are, we hope, we believe, we've worked on them being very scientifically based, where we try and identify levels of human perturbation above which the risk of changing the state of the Earth system may be significantly increased. We do not try and dictate how societies should develop. It's kind of like a bank account. When you go and you get a printout from the bank that says you have this much money, you can use that money lots and lots and lots and lots of ways. You just can't use more than you have or more than you can borrow, proving that you'd be able to pay it back. And it's the same way here, where our currency is not money, it's the resources we're dependent upon. And I do believe that something like the planetary boundaries, and it doesn't necessarily have to be the planetary boundaries, but something like the planetary boundaries is a really important and significant contribution to the process of trying to develop this global this global management of resources. I've done together with Will Steffen, I've done a chapter which tries to look at what's been happening since the 80s. This is difficult to understand just looking at it, but on the left-hand side we have important research milestones. In the 70s we realized that we were creating an ozone hole. In the 80s we realized from ice cores there really was a relationship between temperature increases and CO2 through the history of the Earth. On the right-hand side, you have policy responses. You have the Montreal Protocol in '87 responding to the ozone problem. You have the UNSCC being established in 1990 responding to the climate problem. So there you have on the political milestones do seem to be referring to the research. So you know, this business about politicians never hear research is wrong. But there's a time lag. You'd expect that. But I think this in the middle here, this the international network of ICSU and the WCRP, the IGBP, Diversitas, and growing together to the Earth System Science Partnership and ultimately to Future Earth. I think that spider web in the middle has been incredibly important, and I have actually allowed myself to put planetary boundaries on the research milestone side here, because I think is all part of this process where we're beginning to get this understanding of the Earth system. And I promise you, no university on its own would ever have gotten there. It needed the stimulation from the spider web in the middle. And I also put the SDGs as potentially political milestones that also relate to planetary boundaries on this list. Finally, just a word about the COP process. A lot of people say COP15 was a disaster, a failure. I don't believe it was. I believe if you get into your helicopter and look in the future and you're a historian and look back at COP15, you will say that two really fundamental things happened. One, policy accepted the science. In spite of the fact there was an unprecedented attempt to miscredit the science, the politicians said 2 degrees. They didn't say how, but they said 2 degrees. They accepted the science. The other is you had top leaders, not environmental ministers, at COP15. And you would have had it because UNFCCC is an environmental framework. You had top leaders. Why did you have top leaders? Because it was no longer low politics where you go in and say, is there something in this for me? Yes, no, fine, yes, I'll vote for it. It had to do with the balance of power between countries. That's what high politics is all about. So I think that's really important. Now, in terms of COP21, I think we're in a really exciting place. And I think being able to manage expectations is one of the most important things. And most of the scientists I talk to still say, but it's not going to be enough. And we're not going to get a binding agreement. No, we're not. And I think that's a good thing. Because no country would ever promise in a binding agreement to do more than they knew they could do. And here I've tried to put together what we know about the 3 big emitters and what they've done at various times. And what they promised in the Kyoto is the first one, and what they've got the EU and the USA on the left and China on the right. And then you've got what happened in 2009, and now you've got what's happening in terms of COP21. And what you can see is if we'd gotten a binding agreement in 2009, this is the kind of level that we would have been talking about. And yet now that we've 5 years later, 6 years later down the line, we're looking both for the United States and for Europe at a much better and a much higher target. What's more interesting is the fact that Europeans are now writing domestic. We can't do it with clean development mechanisms any longer. It has to be done on European soil. That's huge. It never made the paper, but it's huge. And so we're in a much better position now. What I think, when you're looking over here at China, you can see the blue line is their current scenario. The red line is their new policy scenario. There came a paper out by Stern last week saying that they were under-promising that they were going to be already reaching the top of their production by 2025. So things are happening at accelerating rate. And to me, that says that countries are beginning to believe in the technology. A, they recognize this is important. B, they're beginning to believe in the technology, and C, they're beginning to believe in the economics of it. Otherwise, they'd still be doing the clean development mechanisms. So I think it's really important that we have the COP process, we have the UNFCCC keeping focus on this. I think it'd be a really, really, really bad idea to keep pressing for and hoping for a binding agreement with respect to targets. A, because I went to 3rd grade social studies in the United States, and I know the American president can't sign on to something like that. But B, because the fact that it's moving and they're moving targets allows them to become more ambitious as the technology and the ability happens. So when I say global environmental management by 2050, a lot of people say, oh, businesses go out and say, just give us a level playing field. Just give us, so everybody has the same rules. Or let's get a global binding. Yeah, but that would require that we have a global governance that has the competence to impose sanctions. I don't really think any of us really want that. So the good news is with the ozone layer, for example, or the ozone problem, the Montreal Protocol, bottom-up processes, democratic processes that led to a conclusion. And I think what we're watching around us now is bottom-up democratic processes that are being used to develop global environmental management. Will we make it by 2050? I certainly don't know, but we have to if we want to continue to develop. Thank you.